What's up, my guys? I'm hoping you're having a good day so far. And today I'm going to talk about mollusca, the locomotion of them. Okay, I gotta get started because this is a pretty big one. Oh shoot, come on, Mr. Slide. Okay, so the foot is basically, oh my gosh, when I was reading this, the foot is like super important. They mainly depend on this to move. It's basically like a muscular foot, and it's for locomotion and anchorage. What I mean by anchorage is to like help them keep them in place. And depending on the mollusk, the way they use it is like different. There's like so many different type of mollusk. It's crazy. And when you're looking at mollusks, the opening of the shell is the same size as the foot. And it's important to note that the foot is extendable and retractable. Like it can get into itself and then like release itself. Like kind of like, we're getting on that in the next slide. And for the gastropods, think about, I said it right here, the snails and slugs. I don't know, I think snails and slugs are kind of cute. They have a foot that takes on like a flat shape, and the bottom is like ciliated. You know, like, remember the protists? It's like ciliated at the bottom. They like flap and move, and they have multiple gland cells that produce a mucus. Like I have a little picture here, you can kind of see it. It's like right here, my pointer. I don't know if you guys can see my pointer or not, but the mucus, and it helps them like glide on for like dry surfaces. And they have like a mucus gland, either opens, it opens at the rear of the anterior end of the foot, and the movement of those gastropods is given by muscular waves. I have like a little video at the end. And the foot is usually like a pedal retractor muscles that attach to the cell and the dorsal mantle. And basically they're able to pretty much like move up and down. Like they move it up and then they bring down the sole. And the waves relies on the like flexing of longitudinal and dorsoventral muscles starting the posterior end of the foot, and the contraction waves can move front to back or back to front, and these are retrograde waves. Okay, let me just like click on this little link, and you can kind of see it contract. It's kind of cool. It's like an underside of the snail like moving. Okay, here we go. Okay, I paused the video. Okay, so I can come back to this because this takes like a while to load. Okay, let me see if I can I'll zoom in real quick. But you kind of see what I'm saying, like the little waves at like the bottom of the snail. The snail's really cute, by the way. But I don't know, if you want to know more about it, on page 486, figure 1319, if you want to read more about that, it will tell you more about how these guys move. It'll give you like there's a little diagram in there that I think is pretty neat. Okay, back to this. Oh shoot. Okay. Okay, for this slide, this is the burrowing portion of it. Some gastropods have a shield-like propodium. Oh yeah, in order to plow through the sediment, propodium is basically the anterior lobe, and basically on the part of the foot, the anterior lobe of the foot, and the rest of the foot is the metapodium. And some even have a flap-like fold of the foot that is used as a source of protection. And augurs are able to burrow by pushing their foot, like thrusting their foot into the ground and holding it in place by enlarging with the hemolymph. And then it pulls this body ahead, like it pulls the body forward. The hemolymph is like a fluid. It's kind of similar to blood in vertebrates, and it basically circulates the interior of the amphipod. And this thrombus forms a claw in order to dig into the ground, and the claws also serves as like a pivot point. And the bivalves can dig at different depths using their blade-like foot, like also called like a hatchet foot. Whoops, I did not mean to go accidentally on that slide. Hold up, let me see. Come on, buddy. Okay, so the bivalve's foot works through muscle action and hydraulic pressure. Oh yeah, just to get more info, bivalves are basically like mollusk that has like a compressed body enclosed with like a hinged cell. Like think about oysters, clams, and like scallops. Some bivalves use their sharp edges, like on their shells to like help them dig. Some use acidic mucus to dissolve the substrate, like limestone, coral, and like dead shells. Some this. I have a picture right here of a shipworm. It's like burrowing in some wood. Like you can see like the grooves. That's the worm right here. Well, it's not a worm, but it's kind of shaped like a worm. And some use their shells to like drill into the ground. Okay, on to the next slide. Okay, this one's probably the most impressive one. Oh wait. Oh, now we gotta talk about how they even like stick to the ground. So, sometimes when you try to pull a snail off, it's kind of hard to like pull them off. Like chitin and limpets, they're able to stick to the ground because of their like broad foot, and their broad girdle can also be added to like get a bit of grip, since they can like clamp down, and it can also it creates a vacuum by raising the inner margin. And there's plenty of bivalves that are permanently attached to the ground through cremating one valve on a surface. And some use anchoring threads, which are also called bicell threads. And they're basically like sticky fibers that are usually made up of protein, and its main function, like I already said, is to attach and to anchor to like certain surfaces. Oh, I also have the most interesting movement. I have like a little video here. I'll play it right here. Okay. So this kind of makes me think, remember that, I don't know if you guys watch SpongeBob, but remember that episode where they take care of a baby clam and the baby clam like jumps out the window? Yeah, it kind of moves like that, and it like flies away after it kisses like SpongeBob and Patrick at the end of the episode. And it just like falls down, like it basically flaps its two valves to like move around, and there it goes, just sinking. Oh yeah, and also, in heteropods, their body is laterally compressed, and unlike the other mollusks we talked about, their shell is reduced, and their foot is more like a fin to like help them swim around. Okay, finally to the cephalopods. They easily expel water out of their mantle cavity in order to swim, and also some of them have radial and circular muscles in their mantle. And the contraction and unwinding, contraction and relaxing of the muscle layers takes in water in the mantle cavity. And the funnel is to mainly help them to turn. And, like octopuses, this isn't an octopus, this is what I have back here, that's a vampire squid. And also to know about, like, squids, they have the greatest swimming speeds out of, like, any aquatic invertebrates. And also, like the cephalopods, they emotionally involved, like, their locomotion's mainly, like, focusing on swimming. And that's why they make up, like, great predators. Of, like, the octopus, like, walking on two tentacles. Like, I have a video of one walking. I don't know, dude, it looks kind of goofy. It looks kind of like a clown. You can kind of see it just walking on his tentacles. I don't know, it just looks so funny to me. Just not a care in the world, just chilling, just vibing. Okay, oh shoot, here's my, works cited. Okay, I had to kind of pause it, it kind of looked kind of glitched, so here's my works cited. And I hope you guys have a fantastic day, so goodbye.